Next, the fishbone diagram helps us identify possible cause of technology-related vulnerability in smart office. We divide the root cause into 6 categories. Under people, issue include a lack of training and human error. For process with security procedure and delay in software update can lead to risk. Equipment-related issue involve unsecure IoT device and unstable network. In the environment category, power outage and poor Wi-Fi coverage can disrupt operation. Under materials, which refer to data, we face problems like encrypted sensitive information and unsecure cloud storage. Finally, in management, the lack of clear cybersecurity policy and insufficient system monitoring increase vulnerability. This analysis help us better understand and address the root cause of smart office security risks.
In our Smart Office IoT project, we used the fishbone analysis to identify the root causes behind the potential security and reliability issues. So we are able to categorize these causes into 4 key areas, which is people, process, environment, and technology. Under people, we found that employees may struggle with work-life balance, privacy concerns, and the need for proper training to adapt for smart technologies. In terms of process, issues like weak security policies, lack of system updates, and poor incident response can expose the office to vulnerabilities. The environment presents its own challenges such as signal interference from walls, high energy demand, and outdated infrastructure in some office buildings. Lastly, under technology, problems like outdated firmware, unstable network protocols, and limited device storage affect the overall performance and the security of the system. So by using the fishbone analysis, we were able to break down these complex problems and focus on specific areas to improve, ensure our smart office is not only efficient but also secure and dependable.
Hi, my name is Umi Khalida. Today I want to highlight the people-related issue that come with implementing a smart office. Firstly, privacy consent are a main issue. Our project report show that many IoT lack proper security, making employee data vulnerable to hacking or unauthorized access. When staff feel they are constantly monitored by smart camera or motion detector, it can cause discomfort or reduce trust in the system. Secondly, there are a problem of digital fainting and blur boundaries with smart systems that are always connected through phone or laptop. Some employees may feel like they are never truly off the clock, which can affect their work-life balance. Another issue is adaptation and training. Not every employee is comfortable using new smart technology without proper support. This can lead to excess or lower productivity. Last but not least, there are lack of transparency, which is if employee don't clearly understand how their data is used, it can lead to distrust between them and management.
During our network configuration review, we uncovered a significant inconsistency in our DHCP implementation. As shown in this table from our report, IoT devices were mistakenly assigned to the IT department, subnet as 192.168.50.0 rather than the dedicated IoT subnet at 192.168.25.0. This misconfiguration occurred. The DHCP pool was not properly aligned with our network segmentation strategy. Why does this matter? First, it creates unnecessary broadcast traffic across department, potentially slowing down network performance. More critically, it violates the fundamental security principle of network segmentation. IoT devices, which are often with most vulnerable endpoints, were placed on the same subnet as workstation. This means if the attacker compromised a smart light bulb, they could potentially private directly to sensitive IT system. In a real-world office scenario, this oversight could lead to severe consequences like data breaches or service disruptions. The fishbone analysis helped us trace this back to a gap in our configuration protocols. We didn't have a standard checklist for verifying subnet assignment before employment.
And today I will presenting on a very important topic, which is investigate environment-related factors when implementing IoT device in real-world environments. So let's start with energy factors. IoT devices are known to help reduce energy waste like turning off light or air conditioning automatically when not needed. That is a big plus. But here is the catch: they need constant power to stay connected and responsive 24 hours for 7 days, so there is a trade-off involved. While we save energy through automation, we also consume energy to keep this device always online. It is important to weigh both sides when planning an installation. Next, we have physical space issue. Sometimes the building materials or wall can block signal, especially Wi-Fi, which many IoT sensors depend on. So the placement of device become very important. For example, camera needs a clear line of sight, and any obstruction can affect their performance. Also, many devices generate heat, so they need good ventilation to avoid overheating. These are small details, but they make a big difference. So, moving on to infrastructure problem. In older buildings, we often face challenges like the lack of enough ports or wiring to support new IoT hubs. Also, if we connect too many devices to the same network, it can cause lag or connectivity issue. Any point of that HVAC system, like B air conditioner, can create noise that interface with curtain sensor. So, checking the building infrastructure is key before installing anything. Now, let's talk about solutions. First, we should run energy audit to see if the smart devices are truly saving energy as expected. Second, before full installation, always test the Wi-Fi in the actual space to avoid signal issue. Lastly, combining both wire and wireless connections can give more reliable performance and reduce the chance of system failure. So it's not just about closing the latest text, but also about understanding the environment where it will be used. Addressing this energy, space, and infrastructure issue early will help ensure a smooth and successful IoT development. Okay. Now, to conclude our presentation, we have explored how the fishbone analysis technique can help us identify and address the root cause of security vulnerabilities in smart office IoT system. By breaking down the problem into four key categories, which is people, process, technology, and environment, we were able to examine the issue more thoroughly and from multiple angles. This method not only allows us to better understand the challenges we might face, but also help us think critically about practical solutions. Most importantly, it gives us a clear structure approach to improve the overall security, safety, and reliability of our smart office setup. In today's digital world, where technology is constantly evolving, tools like the fishbone analysis are essential to staying ahead of risks. So that's all from our group. Thank you.